Welcome to the Copperfield Electric Podcast. I want you to imagine getting this just massive $20,000 surprise bill from your utility company. And it's all just because, like, three of your tenants decided to buy new electric vehicles in the exact same month.
Yeah, it's a terrifying thought for any property manager.
Right. I mean, in the world of multifamily real estate, the seemingly simple act of, plugging a car into a wall is suddenly triggering this massive infrastructural headache.
Oh, absolutely. It's a total game changer.
So if you're listening to this and you're picturing that dusty 1980s electrical panel in your building's basement, you might already be sweating a little bit. But before you write off EV charging as this huge financial black hole, we really need to talk about the mechanics behind the wall.
Because that $20,000 bill is actually entirely avoidable. If you understand the physics of your building's power supply and, well, the legal landscape you are operating in.
Which is exactly why we're doing this deep dive today. We are breaking down the best EV chargers for apartment owners.
Right, because the variables just multiply exponentially the second you add a second or third parking space to the equation.
Exactly. We're moving way past the simple binary of, like, a light switch into this complex web of shared electrical loads, structural limits, and honestly, rapidly evolving state mandates.
Yeah, it's a structural maze out there right now.
It really is. And to guide us through that maze, we are drawing on the deep expertise of today's sponsor, providing like really elite residential and commercial electrical services across Southern California.
And their footprint in this specific multifamily space is just extensive. I mean, they serve all of Orange County.
Right. So we're talking Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, Mission Viejo, and all those surrounding areas.
Exactly. And property owners rely on them for everything from, 24-hour emergency rapid response to really complex electrical retrofits. And it's all backed by a 100% satisfaction guarantee and highly competitive pricing.
So if you manage or own a property, the dynamics we are unpacking today are critical. Because choosing an EV charger for an apartment complex shares absolutely zero DNA with installing one in your own single-family garage.
Oh, none at all. It's a completely different beast.
Right, because in a private home, you have a dedicated panel, you buy a charger, and you just pay your own bill. The math is super simple.
But at a multifamily property, you are suddenly dealing with shared electrical circuits, complex tenant billing systems, and California's really aggressive new building codes.
Yeah, the stakes are just so high, both structurally and financially.
They really are. And to avoid those massive unplanned expenses, we first have to discard the idea that just any charger will do.
Okay, so where do we start?
Well, we have to analyze the hardware based on something called dwell time.
Dwell time. Okay, what exactly is that?
It's basically just how long a vehicle actually sits parked. So for an apartment complex, that dwell time is usually overnight, right?
Yeah.
Roughly, 10 to 12 hours.
Okay, yeah, that makes sense. Let's use that dwell time to sort of filter our options. Because I know when property managers open an equipment catalog, they're usually hit with, like, 3 tiers of charging.
Right, and it is incredibly easy to buy the wrong one.
So walk us through the physical differences of those tiers.
Sure, so at the bottom end, you have level 1 charging, which utilizes a standard 120-volt circuit.
Basically the exact same outlet powering my television or my toaster.
Exactly. And because it's only 120 volts, the electrical flow is highly restricted. It adds maybe 3 to 5 miles of range per hour.
Wow, that is painfully slow. So if a tenant has like a 40-mile daily commute, they would have to be plugged in for over 10 hours just to break even for the day.
Right. And if multiple tenants are sharing a space or someone just has a longer commute, the math simply fails. The car literally cannot absorb energy fast enough to replenish the battery during that overnight dwell time.
Okay, so the physical limitation just makes level 1 totally useless for a shared environment. It's like trying to fill a swimming pool with a leaky garden hose.
That is a perfect analogy.
So let's swing to the absolute opposite extreme then. We see this DC fast charging level 3, I think it is, popping up at grocery stores and highway rest stops.
Oh, yeah, those are everywhere now.
And these units pump out hundreds of volts, right? They can fill a battery in like 30 minutes. So why wouldn't a landlord want the fastest possible turnover for their parking lot?
Well, mostly because of the electrical physics and just the sheer infrastructure required. DC fast charging often requires a 480-volt three-phase power supply.
Wait, 480 volts?
Yeah. To install that at a standard apartment building, you are looking at industrial-grade transformers that are roughly the size of a storage shed. Plus, a dedicated utility service
So
driver.
it's like bringing in a firefighting plane to fill that swimming pool. Just way too much power, too fast.
Exactly. The upfront capital is astronomical. And honestly, it solves a problem residential owners just don't have. You don't need a 30-minute charge when the car is going to sit idle in that parking spot for the next 11 hours anyway.
Okay, so by eliminating the restricted 120-volt option and the industrial 480-volt option, the mathematical sweet spot for overnight dwell time has to be that middle ground, right? Level 2 charging.
Precisely. Level 2 operates on a 240-volt circuit. So it's utilizing the same electrical architecture as like an electric clothes dryer or an oven.
Right, the Goldilocks zone.
But even within level 2, you have to be specific. There are low-power 20-amp versions that add about 10 miles of range per hour, but those can still leave larger vehicle batteries depleted by morning.
So what's the actual target we should be looking at?
The true operational target for a multifamily property is high power level 2, running at 40 amps.
Because at 40 amps, the electrical flow adds, what, 25 to 60 miles of range per hour?
Exactly. It virtually guarantees a full battery by morning, regardless of the vehicle size or how long the tenant's commute was.
Okay, but arriving at this 40-amp hardware creates an immediate physical contradiction, doesn't it?
How do you mean?
Well, if I own, say, a 30-unit apartment building from 1985, my electrical panel definitely does not have the capacity to just add 10 new 40-amp circuits. I mean, the infrastructure behind the wall simply cannot handle that much continuous electrical draw without just melting the main breaker, right?
Yeah, that structural bottleneck is exactly where 90% of multifamily EV projects hit a wall.
I can imagine.
If you just start bolting 40-amp chargers to the concrete and wiring them back to a legacy panel, you instantly trigger a mandatory panel upgrade.
And those aren't cheap.
Not at all. Upgrading a main commercial electrical panel involves engineering plans, city permits, trenching, and utility company coordination.
Ouch. What's the price tag on that?
You are looking at a baseline cost of $5,000 to $20,000, and honestly, often much more than that.
Wow. Okay, so how do we get around that?
Well, there is a software mechanism designed specifically to bypass this physical limitation. It's known as load management.
Okay, let's unpack this load management thing. Because I want to move past the generic marketing idea of just smart technology. How does load management actually manipulate the physical flow of electricity to prevent a massive panel upgrade?
Okay, think of the electrical capacity in your building like water pressure in a house.
Okay, I'm with you.
If someone turns on the shower, the dishwasher, and the garden hose all at once, the pressure plummets. Right?
Okay.
So load management software acts as an active valve system. Instead of giving every single charger a dedicated max capacity pipe back to the panel, you group multiple chargers onto a single shared electrical circuit.
Okay.
The software reads the available pressure in real time and actively restricts or opens the flow of electricity to the individual chargers based on the current demand.
Okay, let me make sure I'm wrapping my head around this.
Right.
If I have a single circuit rated for just one car, but 5 tenants pull in from work at exactly 6:00 p.m. and all plug in simultaneously, doesn't it just trip the breaker? Or do they all just trickle charge agonizingly slowly?
That's where the software intercepts the demand. It prevents the breaker from tripping by dividing the available amperage into smaller fractions.
So for those first few hours, all 5 cars are just receiving a fraction of the maximum charge.
Exactly. But here is where the real optimization happens. I mean, most tenants do not arrive with a battery sitting at 0%, right?
True. They usually just need a top-up.
Right. So as the firm's car hits 100% and stops drawing power, the load management system instantly reallocates that freed up amperage to the remaining 4 cars.
Oh, wow.
Yeah. As the night goes on, the charging speeds dynamically increase for everyone else, ensuring all 5 vehicles are full by morning without ever exceeding the hard limit of that single circuit breaker.
That is brilliant. It drops the multi-charger install cost down to, what, maybe $1,500 to $3,000 per charger instead of a $20,000 panel upgrade?
Exactly. It's a game changer for the budget.
But, okay, looking at this from the perspective of a property manager, my immediate red flag is the reliance on a network connection.
Ah, yeah, that's a common concern.
Right, because what happens when the Wi-Fi drops or the cellular signal goes dead?
Hmm.
Does this active valve system just fail open and pull maximum power, blowing the main breaker in the middle of the night?
That is honestly the most critical question to ask your installer, and it highlights exactly why hardware selection is paramount.
Because cheap hardware probably just fails, right?
Exactly. True commercial-grade load management systems have local hardwired fail-safes. If the cloud connection drops, the chargers do not blindly pull maximum power.
Okay, so what do?
They default to a pre-programmed conservative fallback limit, so say 8 amps per charger. It slows down the charging speed temporarily, yes, but it mathematically guarantees the breaker will never trip. It keeps the building safe and the lights on until the network is restored.
Which really proves why guessing on these installations is just a massive liability. You can't just buy the hardware on Amazon, assume the software will figure it out, and hope your panel holds up. The math has to be verified beforehand.
Oh, 100%. And that verification is called a load calculation. It absolutely must be performed by a licensed electrician before a single piece of equipment is even purchased.
And I imagine a professional load calculation is more than just opening the panel box and looking at the breakers.
Oh, way more. The electrician analyzes historical 15-minute interval data from your utility company. They need to identify the absolute peak demand your specific building has experienced over the past year.
Wow, 15-minute intervals, that's detailed.
It has to be. They then calculate the margin between that historical peak and the physical limit of the panel, factoring in the strict National Electrical Code rules for continuous loads.
Right, because EV charging is classified as a continuous load, right? Meaning it runs for more than 3 hours straight.
Exactly. And because it runs that long, it generates significant heat in the wiring, so the codes require an extra safety buffer.
Which is precisely why you bring in a specialized team like Copperfield Electric. They specialize in performing these exact multifamily load calculations.
Yeah, they tell you the true mathematical reality of your electrical headroom. That way, you can design a load management strategy that actually works safely.
Okay, so once you have established the electrical boundaries behind the wall, you face the physical realities of the parking lot. A landlord has to decide on a billing strategy, and that dictates the physical hardware mounted on the concrete.
Right, because a property owner obviously cannot absorb the cost of a tenant's daily fuel. That cost has to be passed through accurately.
So let's explore those billing mechanics. How does a landlord actually charge the tenant for the power?
Well, for assigned spaces, the industry standard is to use network chargers. We're talking brands like ChargePoint, FLO, or Inalex's JuiceBox. These are super common in California.
And these are the smart chargers, right?
Right. These units have cellular or Wi-Fi modems built in. When a tenant plugs in, they authenticate their session using a smartphone app or like a RFID card.
Okay, got it.
The charger tracks the exact kilowatt hours dispensed and bills the tenant's credit card directly. And then the software company basically just reimburses the landlord for the electricity cost.
Okay, here's where it gets really interesting to me. Do we have to make everything smart?
What do you mean?
Well, introducing modems, apps, and RFID cards introduces so many points of failure. Software needs updating, modems lose signal, tenants forget their passwords. If a property owner just wants to avoid the entire administrative headache of tech support, can they strip away the software and just install a simple, durable, dumb charger?
They absolutely can, and honestly, many do by utilizing a hybrid strategy. It's completely valid. You can install non-networked dumb chargers in, say, shared or guest parking areas.
Right, because without the internal modems and authentication screens, there's just significantly less physical circuitry that can break.
Exactly. And to recoup the electrical costs on a non-network unit, landlords simply charge a flat monthly access fee. Just a set price for the right to park in that specific EV space, regardless of how much power the tenant actually draws that month.
That makes a lot of sense. But whether the charger is smart or dumb, I mean, it is still an appliance sitting out in a parking lot, exposed to the elements and moving vehicle.
Oh, yeah. The physical wear and tear at an apartment complex is brutal.
So landlords really need to budget for physical durability, right?
Absolutely. If the units are outdoors, they require NEMA 4-rated, weatherproof, vandal-resistant enclosures, and perhaps more importantly, you have to budget for proper cable management.
Because a heavy-duty, high-voltage charging cable lying across a dark parking lot is a severe tripping hazard.
And an enormous liability. Plus, it is guaranteed to be run over and crushed by a vehicle eventually. So spring-loaded cable retractors are really a mandatory accessory in a multifamily setting. You have to keep the equipment off the ground.
It reminds us that maintenance means truck rolls and downtime. EV owners renting units expect the charger to work every single night, not just on the day it was installed.
Exactly. Reliability is everything.
Okay, so we have built this incredibly logical ecosystem for our existing building. We found the 40-amp Goldilocks hardware, we employed load management to protect the panel, and we planned our billing strategy.
Sounds great.
But, and this is a huge but, If you are a real estate developer breaking ground on a new project tomorrow, you actually don't get the luxury of making these choices independently anymore. California just totally rewrote the rulebook.
Yeah, the landscape has fundamentally shifted. As of January 1st, 2026, the updated Cal Green building codes take effect.
These are strict, right?
Very. They mandate a massive amount of EV infrastructure on day one for all new construction and major renovations.
Let's dissect the specific mechanisms of this new code. What does the state actually compel a developer to build?
Well, it depends on how you structure your parking. If the property utilizes assigned parking, meaning one specific space is tied to one specific residential unit, the Cal Green Code requires a low-power Level 2 EV-ready receptacle at every single assigned space.
Wait. 100% coverage.
100%.
Okay, the phrase EV-ready receptacle feels like a bit of a legal trap. Does that mean the developer has to buy and mount a physical $2,000 charging station at every single parking spot before they can even get a certificate of occupancy?
No, thankfully not. And understanding that distinction saves developers an absolute fortune in upfront capital.
Okay, phew. So what does EV-ready actually mean then?
It refers strictly to the underlying infrastructure. It means the electrical panel must have the physical breaker space and capacity, the conduit must be laid in the concrete, and the copper wire must be run, terminating in a closed junction box or an outlet right there at the parking space.
I see. So you do not have to purchase the charging appliance itself.
Exactly. But the structural pathway must be fully complete, so a charger can be installed in, like, an hour when a tenant eventually requests one.
Got it. The physical bottleneck is basically eliminated during construction. Now, what if the developer uses an open, shared parking lot model where tenants just park wherever they find an open spot?
The ratios shift for shared parking. The code mandates that 40% of the total spaces must be EV-ready, so the conduit and wiring are buried and ready to go.
No.
But furthermore, 25% of the total spaces must have an actual physical EV charger mounted and operational on day one.
Wow. Okay, so whenever sweeping building codes like this drop, there's always some secondary regulation buried in the cross-references that just catches architects and electricians off guard.
Oh, always.
Where is the hidden trap in the 2026 mandates?
The trap definitely lies in the physical accessibility requirements. These are governed by Chapter 11B of the California Building Code, which aligns directly with the Americans with Disabilities Act.
For accessibility is huge.
Yeah, and installing EV chargers isn't just about pulling wire, it physically alters the layout of the parking lot. An ADA-compliant EV space requires specific concrete trenching, a dedicated access aisle that is at least 5 feet wide, specific slopes so a wheelchair doesn't roll, and really precise height limits for the charger's interactive screen.
So if you pour your concrete without consulting a specialist who actually understands Chapter 11B, you might have to literally tear up brand new asphalt just to widen an aisle or lower a mounting pedestal to pass your final inspection.
Exactly. It's a very expensive mistake to make. And beyond the concrete, there is a major hardware transition happening right now that developers must plan for.
You're talking about the plugs themselves, right?
Yes. For a decade, the industry standard connector in North America was the J1772 plug. But recently, the entire automotive industry basically adopted the North American Charging Standard, or NACS. Technically, it's designated as the J3400 connector.
That's the plug designed by Tesla, right?
Yep. And virtually every major automaker is transitioning to it. So if you are installing physical chargers under the new Cal Green mandate, you must consult your electrician about deploying J3400 hardware, or at least ensuring the units have dual cable capabilities.
So your brand new infrastructure isn't immediately obsolete the moment it gets turned on. Okay, so the 2026 Cal Green mandates are incredibly stringent, but they only apply to new construction and major renovations. Which brings us back to the thousands of existing older apartment buildings across Southern California.
Right, the vast majority of buildings out there.
Property owners are probably breathing a sigh of relief right now that they aren't legally forced to retrofit their entire 1980s parking lot tomorrow. But there is a massive legal loophole they have to navigate, isn't there?
There is, and it's a very specific loophole that transfers a lot of power to the tenant. It's under California Civil Code Section 1947.6.
Okay, what does that do?
It states that a tenant living in an existing rent-controlled or standard lease property has the legal right to install an EV charger in their assigned parking space, entirely at their own expense.
Okay, let's paint the reality of this scenario because this is honestly terrifying from a management perspective. It's kind of like a tenant asking to paint their living room, but with high-voltage electricity and city permits.
It really is.
A tenant wants to tap into the building's high-voltage electrical system. Can a landlord simply deny the request just to avoid the headache and liability?
Generally speaking, no. A landlord cannot refuse a reasonable request under this statute. If you attempt to block it without a valid structural justification, you are actively violating the civil code.
But if a landlord just ignores the issue and passively allows tenants to manage their own separate installations over time, the consequences are disastrous, right?
Oh, absolutely disastrous.
Walk us through the physical danger of letting tenants handle this piecemeal.
Sure. Imagine tenant A hires some budget contractor to run a conduit on the exterior wall. A year later, tenant B hires someone else who taps into a totally different subpanel.
Sounds messy already.
It is. Because there is no overarching load management system in place, these isolated chargers are all pulling maximum power. Suddenly, the building's electrical phases become dangerously unbalanced.
What happens then?
Well, when you draw heavy, continuous power disproportionately on just one side of a panel, it risks overheating the neutral wire. And that can lead to catastrophic equipment failure or, worst case scenario, an electrical fire.
No.
Not to mention, you also end up with this visual nightmare of mismatched conduits and totally different hardware brands just scattered randomly across the property.
So the only real defense against this chaos is proactive control. The landlord can't just say no to the installation, but they can legally dictate exactly how the infrastructure is deployed, right?
Precisely. Under the law, the landlord can mandate that the tenant uses a fully licensed, bonded, and insured commercial electrician, someone like Copperfield Electric.
Right.
The landlord can also dictate that the charger must be compatible with a centralized load management system, which ensures the panel remains balanced and protected as more tenants add chargers later.
So the key takeaway for property owners is to install shared managed infrastructure proactively. It's the only way to avoid a messy, piecemeal patchwork of different tenant installations over time.
Exactly. You control the electrical loads, you control the billing, and you maintain the aesthetic integrity of the building.
And the good news is, property owners do not have to shoulder the entire financial burden alone. Utility providers like Southern California Edison, along with state-funded programs like CAVIP, offer some pretty substantial cash rebates to help offset the costs of deploying this exact type of multifamily infrastructure.
They do, but those rebate pools operate on a strict first-come, first-served basis, and they dry up incredibly quickly.
So you really can't wait around.
No. You need a localized electrical partner who understands the current incentive landscape and can engineer a system that meets all the specific technical requirements of those rebate applications before you even finalize your budget.
Well, we have covered an immense amount of structural territory today. I mean, we filtered out the leaky hoses and the firefighting planes to find our high-power 40-amp Goldilocks charger.
We did.
We explored how load management software acts as that active valve system to protect your existing electrical panel from a $20,000 upgrade. We navigated the specific concrete and wiring mandates of the 2026 CL Green Codes, and we outlined the proactive defense against the chaos of tenant-led installations.
And honestly, the common thread through all of this is that the physical electrical capacity behind your wall dictates every single decision you make out in the parking lot.
Right.
You absolutely must start with a mathematical load calculation.
And whether you need that critical site assessment, a complex load calculation, or a flawless code-compliant installation, Copperfield Electric has the specialized multifamily expertise to help property owners across Orange County get it right the first time.
Exactly. Let the professionals analyze the physics of your building so you can focus on running your property.
You can reach their team directly at 949-806-3735 or 626-622-9694.
They really do transform that murky, high-voltage liability into a clean, predictable, and managed amenity.
They do. Which brings me to a final thought I want to leave you with today. We explored how the commercial real estate world is adapting, physically swapping out the old J1772 hardware for the new J3400 Tesla-style standard on the walls of these brand-new apartment complexes.
Right. It's a huge shift.
But consider the timeline of the secondary automotive market. Over the next 5 years, millions of renters will be purchasing used electric vehicles from, say, 2021 or 2022 cars that still have those legacy charging ports.
Oh, that's a really good point.
With the building codes rapidly enforcing EV readiness and the industry shifting standards, how will the secondary market of older EVs adapt? As the walls evolve faster than the used cars parked next to them, will a massive secondary market for bulky, high-voltage adapters become the new normal for apartment living? Or will the physical wear and tear of those adapters force automakers into a totally different solution?
It really highlights a fascinating friction point between the lifespan of a building and the lifespan of a car.
It truly does. Something to mull over. It turns out, bringing power to the people requires a lot more than just pulling a wire. Thanks for joining us on this deep dive into the architecture of EV charging, and we'll catch you on the next one.